There's no question that the SRT lineup has proven to be extremely popular to those in the market for a performance vehicle. In the past, MasterTech has covered the introduction of the Dodge SRT4, the Chrysler Crossfire SRT6, and the Dodge Ram Truck SRT10 models. Well, now it's time to introduce the newest member of the SRT family of vehicles, the Chrysler 300C SRT8. The SRT8 is full of performance-oriented features that make it a one-of-a-kind experience to drive. Hello and welcome to the December 2004 MasterTech. In this month's program, we'll give you a comprehensive look at what distinguishes the SRT8 from the current Chrysler 300C. Even though there are a number of interior and exterior features, the focus is on a very powerful 6.1-liter Hemi engine that delivers even more performance to the 300C model. We'll give you the details about that engine in just a few moments, but the SRT8 isn't the only vehicle that we're covering this month. We also want to bring you up to date on the Dodge Ram SRT10. Now, we know that you're already familiar with the SRT10, but there have been a couple of significant updates that have been made to the 2005 model, updates that we're sure you'll want to know about. Also, at the very end of today's program, we have some important information from the Daimler-Chrysler Academy regarding wheel torque procedures. So make sure you stick around for this important technical training tip. When you open the hood of the Chrysler 300C SRT8, one of the first things you notice are the legendary Hemi colors. In the classic Hemi style, the engine block has been painted Hemi orange, and the valve covers have that familiar crinkle black finish. But the classic colors aren't what make this engine so impressive. It's the power. SRT8's 6.1-liter Hemi engine produces 425 horsepower at 6,000 RPM and 420 pound-feet of torque. The 6.1-liter Hemi engine is based on the 5.7-liter engine that you're already familiar with. The difference is that this one has been bored out 3.5 millimeters to increase displacement. Also, the compression ratio is now 10.3 to 1, a significant increase from the 5.7 liters 9.6 to 1. Now, this would be a good time to mention that similar to the 5.7-liter engine, this engine is a non-freewheeling design. Along with the larger bore, some of the engine's internal and external components were redesigned. The crankshaft has been modified for the new application with revised counterweights and a 4-bolt tone wheel. Also, the crankshaft itself is now constructed from forged steel rather than cast iron for strength and stiffness. The rod and main bearings are different material compared to the 5.7-liter for higher load capacity. The 6.1-liter accessory drive belt is shorter than the 5.7-liter application. This is to maintain similar accessory drive speeds with higher engine speeds. In fact, the 6.1-liter SRT8 engine will spin nearly 15% faster than the standard 5.7-liter, moving the red line up from 5,400 to 6,000 RPM with electronic cutoff at 6,400. Now, to fill up those large bore cylinders, the pistons are larger. The connecting rods have been modified as well, and the assembly uses a floating piston pin design. Do not reuse the clips. Small distortion upon removal may cause unseating at high speeds. To keep the pistons and cylinders cool, 4 double oil jets have been attached to the base of the main oil gallery. Oil from the jets spray the bottom of the pistons for improved cooling. Use care when removing internal components to avoid bending the tubes, as they require accurate targeting for proper cooling. Now, moving up the engine to the cylinder heads, you'll find that they're now a high-flow design with larger ports. In addition to the increased flow, the heads feature common left and right head gaskets. The valve train on the 6.1-liter engine also has some notable features. The camshaft is a billet steel design with higher lift than the assembled style 5.7-liter cam. Also, hollow stem valves on both the intake and exhaust side that are larger than those on the 5.7-liter. The exhaust valves are sodium-filled in order to improve heat dissipation. The valve train will also incorporate slightly longer intake and exhaust push rods as a part of the design. Remember, always use extreme care to ensure proper seating of the push rods to the rocker arms when securing the rocker shaft screws. The intake and exhaust valve springs have been color-coded to make repair or replacement easier. The timing drive on the 6.1-liter engine receives a 4-leaf tensioner spring. The 5.7-liter continues to use a double-leaf design. The SRT8 requires engine oil that you may have encountered in other applications. 0W40 Mobil 1. This is the factory-fill synthetic motor oil. For increased oil pressure, the oil pump uses a new spring on the pressure relief valve. And a modified oil pan with a revised windage tray has also been installed to help maintain oil pressure during cornering and high engine speeds. Now, as you already know, a powerful engine like this one needs to breathe. And the 6.1-liter engine does so through a modified air cleaner and a new aluminum intake manifold. SRT engineers have designed this manifold with larger diameter runners to provide the SRT8 with increased flow at higher RPMs. For increased flow on the opposite side of the cylinder head, the exhaust manifold on the SRT8 is a true header design, meaning individual tubes for each cylinder. They're constructed of steel tubing encased in a stainless steel shell. This is sometimes called an air gap design, which insulates the pipes. Headers reduce exhaust pressure buildup and at high RPM help to extract the exhaust gases from the cylinder. The addition of headers to the 6.1-liter engine resulted in a 12 horsepower gain. The SRT8's exhaust system uses larger diameter tubing that routes exhaust gases to dual pipes at the rear. The engine cover typically found on the 5.7-liter engine is not used on the 6.1-liter version. Instead, 2 smaller wire covers are featured on the 6.1-liter. They're attached with ball studs to the head covers. Along with the engine itself, the SRT8's engine-related systems have some features which are different than those in 300C 5.7-liter applications. We'll discuss those next, beginning with fuel and ignition. Fuel flow is critical in a performance-oriented vehicle such as the SRT8. So the fuel injectors and the fuel pump for the 6.1-liter engine are designed to maintain the required output for a performance application. In fact, the fuel pump is unique to the 6.1-liter engine. It's a high-output design and should not be installed on the 5.7-liter version of the 300C. There's no exhaust gas recirculation or EGR system on the SRT8, and it does not have the multiple displacement system or MDS that the 5.7-liter version of the engine carries. For maximum performance, the 6.1-liter engine operates on all 8 cylinders at all times. Unlike the 5.7-liter engine, the 6.1 will require the use of premium fuel. 91 octane or higher is recommended. Like the 5.7-liter, the 6.1-liter design has 2 spark plugs per cylinder. However, the 6.1-liter uses a coil-on plug design for all plugs. The coils sit directly on top of the plugs, eliminating the need for the secondary ignition wires. The spark plugs in the 6.1-liter feature dual platinum tips and are in a colder heat range than the 5.7-liter plugs. The gap should now be set to 50 thousandths of an inch. Do not use 5.7-liter plugs since the heat range is not compatible with the 6.1-liter. Next, we'll look at our final system related to the SRT8 engine, the cooling system. With engines used in performance applications, heat removal is an essential part of the package. On the 6.1-liter, the water jackets allow a large amount of coolant to flow through the block. To support the flow, the cooling system capacity on the 6.1-liter is larger than that of the system used in 5.7-liter applications, and a larger cooling module has been installed. Now, I know that so far we've given you a lot of information to digest about a new engine, but here's a tip. You just might see this 6.1-liter engine used for other applications in the near future. Next, we're going to put the SRT8 on the hoist so we can look at notable drivetrain features. The SRT8 will come equipped with the NAG1 transmission. This transmission was the focus of a MasterTech program earlier this year. See the April 2004 MasterTech release for a general introduction to the NAG1. This particular NAG1 transmission has modifications to its control system that sets it apart from the 5.7-liter application. There's a unique transmission control calibration for the SRT8. The new calibration changes the shift points, allowing the SRT8 to rev just a little higher before making each shift to the next gear. The auto stick feature on the SRT8 was designed to use modified logic. The new calibration is more responsive to driver input and will complete any shift as long as it's a reasonable shift request and falls within the limits of safe engine operation. The SRT8 driveline has been designed to accommodate the performance of the 6.1-liter Hemi. A 4-bolt flange has been added to both the front and rear of the prop shaft to transmit torque from the transmission to the rear axle. In addition to the prop shaft, the rear axle is also different from 5.7-liter applications. The 300C SRT8 is equipped with a 215mm rear axle that provides a 306:1 ratio. Well, that's it for the drivetrain. Next up, the SRT8's chassis features. The steering gear and ratio are the same as on the 300C, but the suspension and brakes have both been designed for the SRT8 application. The suspension geometry is basically the same, but all of the components have been redesigned for the higher performance levels of the SRT8 version. The road-tuned suspension is designed to give the SRT8 superior handling characteristics in every situation. Probably the most recognizable suspension feature is one that you'll be able to see even before putting the SRT8 up on a lift: the ride height. It's been lowered by 1/2 inch to provide not only a sportier look, but also better handling characteristics. Once you do get the SRT8 up on a lift, you'll find that the springs, shocks, and bushings are all new. Load leveling shocks are a standard feature on the SRT8. However, it should be noted that the SRT8 is not intended for trailer towing. Another redesigned suspension component: larger stabilizer bars. Both the front and rear stabilizer bars were increased in diameter for the SRT8. The front stabilizer bar measures 30 millimeters, and the rear stabilizer bar measures 15 millimeters. Now, the knuckles are yet another redesigned suspension component. These were changed in order to provide room for the calipers as well as clearance for the tires. The standard equipment tires on the SRT8 are 20-inch Goodyear Eagle F1 3-season non-directional tires. A 4-season version of the same tire is also available, but only as an option. All tires are mounted to 9-inch wide rims. If the vehicle is equipped with the standard 3-season set of tires, the tire widths vary between the front and rear of the vehicle. The front tire width is 245 millimeters, while the rear width is 255. If the optional 4-season tires are selected, all 4 tires will be the same width, 245 millimeters. There will be no spare tire included with the vehicle. However, it will have the tire fit system, which includes an inflator, sealant, and instructions for operation. Just behind those enormous wheels and tires are the performance brakes that are included as standard equipment on every SRT8. 4-piston calipers in both the front and rear provide more grabbing power, and they have a lot more to grab onto because the SRT8 also has larger rotors, which are ventilated in both the front and rear. Similar to most other systems or calibrations found in the SRT8, the electronic stability program has been recalibrated to match the high performance characteristics of this application. Well, that does it for the features we wanted to show you underneath the SRT8. So let's move on to the exterior. Now, earlier in the program, we mentioned the lower stance of the SRT8, but there are a few more exterior differences that help make it stand out. Let's start at the front end. The front fascia has been modified with integrated air ducts that are for brake cooling. These air ducts route air across the rotors and calipers anytime the vehicle's moving forward. The lower edge of the rear fascia has been extended to assist in airflow. The rear fascia also incorporates the sensors for the park assist system, a standard feature on the SRT8. A functional rear deck spoiler and SRT8 badging complete the exterior modifications. The spoiler will increase downforce at highway speeds without increasing drag. Now let's wrap up our SRT8 portion of the program by checking out the interior. As well. In fact, they look more like two individual bucket seats, yet the center seating position still remains. Back in the driver's seat, you'll find that the pedals are not only power adjustable, but they're also included in the memory system. In the instrument cluster, the SRT8 has a couple of new readouts that warrant a mention. Engine oil pressure and oil temperature are now part of the cluster display. And the speedometer was also reworked to show a top speed of 180 miles per hour. Well, that completes our first look at the latest release for the SRT lineup, the Chrysler 300C SRT8. Now, as promised, we're going to take a brief look at another member of the SRT family of vehicles, the SRT10. The Ram Truck SRT10 made its debut on MasterTech just a little over a year ago when it was introduced to you as a new model. Well, the SRT10 is still around in its original form, but for 2005, Dodge has added a new model, the Quad Cab SRT10. Now, the new body is the big update for this model year, but there are also a couple of differences between the standard and available equipment found on both models, so we'll quickly mention those. The Quad Cab will only be available with the 48RE automatic transmission. No manual transmission is available for the Quad Cab version of the SRT10 at this time. The standard cab SRT10 will continue to offer only a manual transmission. Under the hood, the Quad Cab SRT10 is practically the same as the standard cab SRT10. The V10 engine will continue to use the JTEC controller. All Quad Cab SRT10s will be equipped with 4-season tires, and unlike the standard cab, the Quad Cab SRT10 is tow-rated. In the interior of the Quad Cab, a heated backlight is available as an option. This is the same as the system used on the base DR1500 Quad Cab. Well, that's all we have to share with you today regarding the Chrysler 300C SRT8 and updates to the Dodge Ram SRT10. Be sure to join us next month when our topic will be tire pressure monitoring systems. Now, just as I promised at the head of today's program, we have some technical training tips from the Daimler Chrysler Academy regarding wheel torque procedures.
Hello, my name is Glenn Cantarella. I work with Daimler Chrysler Academy. I'd like to welcome you to a special technical training tip on wheel torque. The reason we want to take a moment of your time to go over wheel torque is most technicians understand that a wheel must be torqued when it's reinstalled on a vehicle. They may not have the time to properly do that. We want to try to reinforce why it's important to torque the wheel. One of the issues that a wheel that's not properly torqued can set up is warpage of the brake rotor. Now, a customer may not notice a problem with the rotor being warped initially, but over time it can cause a roughness issue with thickness variation in the rotor. So let's take a moment, take a look at the wheel, and look at the proper torquing sequence when we install a wheel on a vehicle. The torque pattern for our vehicles can be found in the service manual in area 22, Wheels and Tires. There will be a graphic showing the 5 lug nuts and the sequence they should be torqued. The reason it's important to properly torque a wheel is an improperly torqued wheel can cause a distortion in the rotor. A customer will not notice this distortion immediately as the brake pads will both be in unison riding on the floating caliper. What happens is the high spots on the rotor wear down, setting up a thickness variation. Keep in mind that a typical human hair is 90 microns. A typical rotor specification for runout is 25 microns. 25 microns is about 1/1000th of an inch. It only takes 18 microns of thickness variations to set up a pulsation at the brake pedal. Now, a typical customer will notice a pulsation after about 3 months of driving. So let's take a moment and we'll properly torque a wheel on a vehicle. We've already mounted this wheel to the vehicle. It's important to snug the bolts by hand before you do your final torque. What this will do is it'll center the wheel on the hub and allow an even clamping force when you go to torque the wheel. I'm about to torque the wheel in the vehicle. My torque wrench is set to 100 foot-pounds. This particular vehicle, 100 foot-pounds will be the target torque. This is a 2004 Grand Cherokee. I have an assistant in the car right now stepping on the brake pedal to hold the wheel still while I do the torque. You can either have someone step on the brake pedal or let the vehicle down and let the partial weight of the vehicle hold the wheel still. Keep in mind you have to follow the star pattern that is outlined in the service manual while you torque the wheel. We've mounted a dial indicator to demonstrate the runout on the vehicle. The typical specification on a vehicle rotor without the tire mounted should be 1/1000th of an inch. With the tire mounted, you can have up to 2/1000ths of an inch. As I rotate this tire, you can easily see that this vehicle is well within the specification. We've disassembled the left side of the vehicle just to demonstrate the installation of a new rotor. First part of the process, you want to make sure your surfaces are clean. That would include inside of the wheel and the hub surface. I'm using a little bit of Scotch pad to clean this up. It's important not to remove any metal from the surface when you're cleaning it. You just want to get the debris away so you have a clean mating surface onto the rotor. And again, you want to do the same process on the hub. Any extra material, such as rust or road debris that's in there, you just want to knock it off so you have a nice clean surface for the rotor to mate with the hub. When installing a replacement rotor from Mopar parts, you notice that there's a paint dot on rotors for Grand Cherokee vehicles. The paint spot on the rotor indicates the low spot of the rotor. This should correspond to the paint spot that's on the hub, which will indicate the high spot. This allows you to install the rotor match mounted onto the vehicle. It's a standard procedure when replacing a new rotor on a vehicle. Check for runout of the new rotor. I've mounted the rotor on the vehicle and I've tightened the lug nuts to 10 foot-pounds using the star pattern that we talked about previously. Once you do this, mount the dial indicator, turn the rotor, and see what your measurement is. If it's not within 1/1000th of an inch, you'll have to remove the lug nuts, turn the rotor, index it to the next lug nut, and repeat the procedure. If you're unable to get this within 1/1000th of an inch, you'll need to do an on-car brake lathe. We've already discussed one method to install the wheel using a conventional handheld torque wrench. We have another method available using these torque sticks. These sockets will limit the amount of torque that's applied using a regular air gun. It's important to remember to have the bolts already snugged before you go for your final torque with the gun. You will still follow the same star pattern that we discussed earlier in the program. These tools are available through your PSC catalog. Using the sticks, you can see we're still well within the specification after torquing the rotor. The last thing we want to cover today is how sensitive these rotors really are. I've over-torqued 2 of the lug nuts on this rotor, and as you can see as we turn the wheel, there's about an extra 1/1000th of an inch of deflection in this rotor. This would set up an unsatisfied customer as the customer come back eventually with a pulsation in the brake pedal. That wraps up this technical training tip. If you have any questions or any insight you'd like to share with us, certainly please email us or give us a call. My name is Glenn Cantarella, and we'll see you next time.